So here we have a trapezium-faced prism. Remember, the volume of a prism formula says work out the area of the face. So in this case, that's going to be the area of the trapezium, and then times it by the depth, which in this case is 18 centimeters. So I have to work out the area of this trapezium. Now remember, in a trapezium, you have a pair of parallel sides, and the formula goes a half of the sum of the parallel sides, that's 8 plus 14, times the distance between them, and that's 5 in this case. So we can go to the calculator and do a half times 8 plus 14 in brackets times 5. That's going to get us 55 square centimeters if we do that. Then that's the area of my face, 55 square centimeters. I've now got to times that by the depth, got to times it by 18. So 55 times 18 will get me my final answer. You'll notice in some of these questions I've been using the FISNUS, and in other of these questions I've been a little bit more relaxed. So the FISNUS is there as a framework that you can use to guide you through a question, but if you want something a little bit more relaxed, or if you think you've got it without needing to write down that formality, that's absolutely fine. Now here's a cylinder question, and we were asked for the total surface area of the cylinder. There's quite a lot to remember about the surface area of a cylinder. First of all, we're going to break our cylinder up into a rectangle and two circles. The idea is those two circles form the top and the base. So there's the top of my cylinder, and down here I've got the base of the cylinder, and that's those two circles over there. The rectangle would curve around in order to make the curved part of the thing. So obviously the area of each of the circles is pi r squared, and in this one the radius is 6. So pi times 6 squared would do both of my circles. The height of my rectangle is 15 centimeters. But this length over here is the one we really need to pay attention to. If this length over here wraps all the way around that circle, its length must be the same as the circumference of the circle. 2 times pi times r, which is 6. So that's that length times that height for the area of my rectangle. 2 times pi times 6 times 15. And that's getting me altogether 565.49. Now of course you can remember all of this just as formulas that you've memorized, but if you haven't memorized those formulas, or you want to just be sure, that's how we break it down. So the total surface area is that rectangle, 565.49, plus 2 lots of those circle areas that we've got there. The circle areas are pi times 6 squared, which comes out as 113.10. So putting all that together, I'm getting a grand total of 791.68. So I'll write that as 791.7 to 1 decimal place. So quite a lot going on in this question. Surface areas of cylinders do have several bits to keep track of, so this is a good one to go back and look at again at some point before your exam. Here we have a volume of a cylinder question, and these by comparison are much easier. Like any prism, the volume of a cylinder is the area of the face, which in this case is a circle, times by the depth of the prism, which in this case is 25. So let's focus on the area of this circle. To work out that area, I'm going to need its radius. Now I don't have the radius, I have the diameter. So the radius is half the diameter, 15, and the area of that circle is pi times r squared, pi times 15 squared. So typing this into my calculator, gets me 706.86 centimeters squared. For the volume, I take that 706.86 and I multiply it by that 25. So the volume is 706.86 times 25. That is 17,671.5. 17,671.5 cubic centimeters. A cuboid measures 25 by 12 by 8, and I want to calculate the volume. Well, it's base times height times depth, and I have a base and a height and a depth. It doesn't really matter what order they go in, because they're all being multiplied together in my formula. 25 times 12 times 8. Job done. 25 times 12 times 8. That's going to be 2,400 centimeters cubed. Now I want to write this volume in cubic meters. Okay, so this one is very easy to mess up on. We of course know that 100 centimeters is the same thing as 1 meter. Now, for cubic centimeters and cubic meters, this is going to change. For squared centimeters, for instance, 1 meter squared is 100 squared centimeters squared. And 1 meter cubed is 100 cubed centimeters cubed. So do pay attention. When these squares and cubes appear, we've got to do squares and cubes over here as well. And of course, technically I could put squares and cubes on my ones, but they don't make any difference, so I'm not going to bother. So this is our exchange rate between meters cubed and centimeters cubed. If I want to turn 2,400 centimeters cubed into meters cubed, I've got to divide by the centimeter cubed number, which is 100 cubed, and times by the meters cubed number, which is just 1. So altogether, I'm guessing 0.0024 cubic meters. It's not just a case of dividing by 100, because we are dealing with cubic units. So here's another question. I want to work out the surface area of this cuboid. Now, the easiest way to visualize this is to draw a net. So remember, there's a bit of this we can't see back here. What I'm going to do is imagine this to be a box. I'm going to take off the lid, and then I'm going to flatten out all the sides. So the base of the box down here, that's what I've drawn there, and it's got 4 sides attached to it. And the lid is over here. So the base of my box is 8 by 2 centimeters. So that is 16 centimeters squared, and that has to match up with the lid, 16 centimeters squared. This side of the box over here is 8 times 5 is 40 centimeters, and that must be matched on the other side as well. The shortest, smallest side of the box is 2 by 5, 10 centimeters, and that's matched up there. So now the surface area is all of these things added together. 2 40s and 2 10s makes 100, which is very convenient. 2 16s makes 32, so it's 132 square centimeters. Now we have a question about a cake. The cake can be made in either a cylindrical tin or a square-based tin. Our cylindrical tin has a radius of 10 and it's 5 centimeters high in that tin. We want to know what the volume of the cake is. Correct to 2 significant figures. So, to work out the volume of a cylinder, I do the area of the circle, which is pi r squared, pi times 10 squared, and then I times it by the height of the thing, or the depth of the thing, which is 5 centimeters. So I've got the area of the circle, pi times 10 squared, and that's going to be times by 5. Let's see what that comes out as. So I've got pi times 10 squared times 5, and we're getting 1570.796 and so on. Now that's not their answer, but I haven't rounded it to two significant figures yet. So my first two significant figures are the 1 and the 5. Looking beyond the 5, I realise I would have to round it up to a 6. And now both of these digits need to have the right place value. That 6 is in the hundreds position, so I need to fill in a couple of zeros. And so there's our answer rounded to 1600 centimeters cubed to two significant figures. And that concludes the solutions for this worksheet.